Hello, this introduction about epidemiology. Uh, we will talk about what is epidemiology. Epidemiology is the study of a group of population, not exactly the 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 person is about the population, health related. So the epidemiology is the study of distribution and determinants of health related within a population. Okay? So not exactly about one person. Yes, it's a study about uh, a, a population. Okay? Uh, Epidemiology usually uses rates. Uh, so epidemiology sees the disease within a group, not property of an individual. The tools of epidemiology are numbers. Numbers in epidemiology are ratios, converted into rates. Okay? You have numbers, okay, among a population. The denominator is key. Example, who is at risk for a particular event or disease state? We will use these, these people is a denominator. Compare the number of actual cases with the number of potential cases to determine the rate. Okay? Rate is actual cases over potential cases. So numerator is the actual cases, okay, with the disease. And denominator is who is at risk, okay, potential cases, who is at risk, okay. Term incidence is the rate of which new events occur in a population. The numerator is the number of new events that occur in a defined period. The denominator is the population at risk of experiencing these new events during the same period. Incidence rate is equal number of new events in a specified period over number of persons exposed to risk of becoming new cases during this period. Attack rate is a type of incidence rate in which the denominator is further reduced for some known exposure. Focus on acute condition. Okay, attack rate has a focus on acute condition. Okay, the prevalence rate. All persons who experience an event in a population. The numerator is all individuals who have an attribute or disease at a particular point in time or during a particular period of time. Okay? The numerator is not just the beginning the disease. It is all who have all already have and who, how who develop the disease. Okay? The denominator is the population at risk of having attributes or disease at this point in time or midway through the period. Prevalence rate equal all cases of disease at a given point or period over total population at risk for beginning cases at a given point of period. Time it down. The time usually 100,000. Okay, rates is usually over 100,000. Prevalence rate. Point prevalence at a specified point in time. Period prevalence during a specified period or span of time. Focus of prevalence is in a chronic condition. The relationship between incidence and prevalence is incidence times duration. Okay? Prevalence what? Incidence cases or new cases are monitored over time. New cases join pre-existing cases to make up total prevalence. Prevalent cases leave the prevalence pot in one of two ways: recovery or death. Okay? If you develop some disease, if you recover, you're out of prevalence. And if someone deaf, it's out of the prevalence. Okay? Morbidity rate. Rate of disease in a population at risk. Refer both incident and prevalent cases. So what happens with incidence and prevalence if a new effective treatment is initiated? The incidence no change, but the prevalence decreases if you have a cure, okay? If you have it out of the disease. New effect vaccine gains widespread use. You will decrease incidence and prevalence. Number of persons who dying from the condition increases. The incidence no change, but you decrease the prevalence. It's not good, but the prevalence will decrease if people die. Additional federal research dollars are targeted to a specified condition. No change, neither instance, neither prevalence. Behavioral risk factors are reduced in the population at large. Both you reduce incidence and the prevalence. Like if you decrease the food and decrease the weight of the population and exercise habits, you decrease the diabetes and hypertension. So you decrease the incidence and the prevalence of diabetes. About COVID-19, if you use mask, if you wash your hands better, you will decrease the incidence and the prevalence of COVID. Okay? contact between infected persons and non-infected persons are reduced. For airborne infection disease, you will decrease incidence and prevalence. For no-infection disease, you will not change the incidence neither prevalence. Okay? Recovery from the disease is more rapid than it was 1 year ago. So the incidence no change, but you will decrease prevalence. But if you have a long-term survival rates for the disease are increasing. Example, hypertension. 40 years before 40 years, you have hypertension, people die for myocardial acute infarction and stroke. But with better condition in health system, you have the prolonged increasing in survival rates. So you will increase the prevalence. You have more people with illness, with disease. Crude rates. Crude rate is actual measures rate for a whole population. Specific rate. Actual measured rate for a subgroup of population. Example, crude rate is the disease in all population. Okay? But if you divide it between less than 50 years and more than 50 years, you will divide it by specific, less than 50 to more than 50, okay? Age specific, sex specific for men or women, okay? Male and female. Crude rate can be expressed as a weighted sum of age-specific rates. Each component of that sum has the following form. Proportion of population in the specified age group times age-specific rate. Standardized rate or adjusted rate. Adjusted to make groups equal on some factor. Example, age, and as if statistic for comparing groups. Removes any difference between two populations based on the standardized variable. This allows an uncontaminated or unconfounded comparison. This table is to exemplify this question. The last line will have the crude rates. So, the crude rates, in the crude rates, you have in the population A, the crude rates, you have 2.3 per thousand people. Okay? In the population B, you have 2, and the population C, you have 1.6 per 1,000 people. Why is it different? Because if you have one case for 1,000 in population A, but you have 2 for 2,000 and 3 for 3,000, the same proportion. But you have more older in this population, 6,000, than in the population C, in the population A, you have 6,000, and the population C, you have 6,000, but you have 3,000 older, and you have 3,000 older, and you have 1,000 older. So the crude population will be different. But if you stratify this population, you have specified rates, you have the same prevalence rates in this population. Okay? So why does population A have a higher crude rate of disease compared with the population C? Okay? It's a common question. Types of mortality rates. Crude mortality rate. Deaths over population. Cause specific mortality rate. Deaths from a cause over population. Case fatality rates. Deaths from cause over number of persons with the disease of cause. Proportionate mortality rate. Deaths from a cause over all deaths. Okay, to exemplify, we have two questions. The first one is can read. So, if you have increased the time of survival, you will increase the prevalence of the disease. Okay, the incidence will not change, but the number of prevalent cases will increase. Okay, because the other question. So the increased prevalence uh, and stable incidence can attribute to factors which prolong of duration of disease. Okay, so you improve quite care is the best explanation to increase prevalence and no change incidence. Okay, it's all for today. Thank you very much.